we are to decode the result of this given, the logarithm of 64 to the base 2, without using any calculators. We have two different methods that we can use here, but these two different methods uses specific types of concepts, content, or properties. Let's start with the process where we are going to equate this to any variable, let's say x. If we are going to equate this entire logarithm to x, then we can use the transformation of a logarithm to the equivalent exponential equation. And with that, we're going to follow the simple process. The logarithm of any ax coefficient to the base b, if it's equal to any variable a, this can be transformed, and of course vice versa, to the exponential equation where we take the base of the logarithm. The equivalent here would be your exponent, and your coefficient is your a. So we are going to transform again this given logarithm, since we equate it to a certain variable to which the exact value of the given. And with that, we can have here, the, again, let me write it here, the logarithm of 64 to the base 2 is equal to a variable x. And transforming into an exponential equation, you will have 2 as your base to the power of x is equal to 64. Now that we have this, we are going to use now the topics on exponential equations, specifically the property of equivalent exponents in solving for the value of x, because we cannot take the x root of both sides here. The property of equivalent exponents tells us this: if you have an exponentiation to the base m, and it's equal to another exponentiation with the same base but different exponent, the property of equivalent exponents tells us that if we have the same bases, we can say that the exponents are just the same, or they are equal to one another. Here, in short, we can write 64 as base 2, and we know that 64 can be rewritten as 2 to the base 6, because we have 2 times 2, that's 4, times 2, 8, times 2, 16, times another 2 is 32, and there are 6 2's multiplied by each other, you will get 64. We are just lucky that this is exact, but if it's not exact, we have another process for that as well. But for this, using the property of equivalent exponents, since we have the same bases, we can say that the value of x is equal to 6, to which is the exact value of the unknown, since x is the representation of the exact value of logarithm 64 to the base 2. So this is the answer for this given logarithm. The second process I have mentioned earlier is a process as well using properties and theorems of logarithm. If we know already that 64 can be written as 2 to the power of 6, we can use other method aside from this method here, and we can write here the logarithm. Of course, that was 64 to the base 2. And since 64, if we know that already that it can be written as 2 to the base 6, 2 to the power of 6, and then we have here to the base 2. There is a property in theorem rather in our logarithms that if we have this expression, we can write the exponent of this coefficient here under the process of multiplication. So this could be equal to 6 times, or even without the parentheses, you can write it here, logarithm of 2 to the base 2. Now that we are done with this, again, it is a implication of a theorem. Now that we are done with this, notice this logarithm here. Another property in logarithm is that if we have a logarithm of a number to a base of the same value of the coefficient, this is entirely equal to 1. And as therefore 6 times 1, you will have 6. This is the same value as the answer earlier, using a different process. So these two values, the same values of 6, is the entire equivalent of the expression earlier. We could use this method or this method depending on your preference. So we have decoded now the result for the logarithm of 64 to the base 2. That's mission accomplished.